When the force applied on a stationary body, it moves, and a work is said to be done by the force on the body. But if the body does not move on applying a force on it, no work is said to be done by the force on the body. The work done by a force is measured as the product of the force and the distance moved by the body in the direction of a force. So work done will be equal to force into distance moved in the direction of a force. The SI unit of force is Newton and the SI unit of distance is meter. So the SI unit of work will be Newton meter, which is written as Joule, after the name of the scientist J.P. Joule. In short form, we write Joule as capital J. So 1 Joule is equal to 1 Newton into 1 meter. And so we can define like this: 1 Joule. 1 Joule of work is said to be done when a force of 1 Newton moves a body by a distance of 1 meter in the direction of a force. You must have experienced that more you ride on a bicycle or more you run all around the playground, more you feel tired. The reason is that a lot of energy has been spent in doing work by you. Thus, to do more amount of work, you need more amount of energy. Hence, we can say that there is a direct relationship between work and energy. Similarly, the work done on a body in changing its state is said to be the energy possessed by the body. For example, if a body is moved from the ground to a height, work is done on the body against the force of gravity, and the body at the height is said to possess energy. So we can define energy like energy is the capacity to do work. Energy is measured in the same unit as work. Therefore, the SI unit of energy is Joule. A body is said to possess an energy of 1 Joule if 1 Joule work is done to bring the body in that state. That is, a force of 1 Newton moves the body by a distance of 1 meter in the direction of a force. Another unit of energy is calorie. 1 calorie is equal to 4.2 joule. A bigger unit is kilocalorie, where 1 calorie is equal to 1000 calorie. Next is the conservation of energy. We have read that in transformation of energy from one form to the other required form, some part of energy is changed to non-useful form also, but the total sum of the useful and non-useful energy is same as the energy being transformed, that is, energy remains conserved. For example, if 100 joule of electrical energy is converted to mechanical energy in an electric motor, it is possible that 60 joule is the mechanical energy and remaining 40 joule may be the heat and the sound energy. Thus, the law of conservation of energy can be stated like this: the total energy is always conserved in each transformation of energy. In mechanical energy, for transformation between the potential energy and kinetic energy, the law of conservation of mechanical energy takes the following form. In absence of friction, the total sum of potential energy and the kinetic energy remains constant. This can be easily understood by the example. So the first example, take the roller coaster. A roller coaster operates on the principle of conservation of energy. Initially, some work is done to put the roller coaster car at the position A. This you can see on the screen also. This work done is stored in roller coaster in the form of potential energy. Say it is E, capital E. Since it is a stationary at A, its kinetic energy is what? 0, because kinetic energy means movement should be there. When no motion is there means no kinetic energy is there. So kinetic energy at point A is 0. As it starts coming down, the potential energy changes into kinetic energy, and so the potential energy what? Decreases. And which energy increases? Kinetic energy increases. So when the roller coaster reaches at B on the ground, then the potential energy becomes 0, as it is converted into what? Kinetic energy. And so the kinetic energy at B is E. Due to this kinetic energy, the roller coaster rises to reach the point C. During the motion from B to C, again the kinetic energy changes into potential energy, and therefore the potential energy increases and it becomes what? E1. While the kinetic energy decreases to what? Decreases to capital E minus capital E1. Thus, at each position A, B or C, the total sum of potential energy and kinetic energy remains what? Same, and this is equal to E. Here what? We have neglected the friction. Clear? Next, a vertically falling ball. A ball falling vertically downwards from a height is another example of conservation of mechanical energy. When the ball is stationary at a point A at a height h above the ground, potential energy is maximum. Let the maximum potential energy is E, which is equal to the work done in lifting the ball from the ground to the point A, while the kinetic energy is what? 0 there. Clear? As the ball starts falling down, its potential energy changes to kinetic energy. At point B, what happens? Half of the potential energy converts into the kinetic energy. So at B, the potential energy is E by 2 and kinetic energy is also what? E by 2. On reaching the point C on the ground, whole of the potential energy converted into which energy? Kinetic energy. So at point C, potential energy is 0 and kinetic energy is E. Thus we notice, or we can say that during the vertical fall of a ball, if friction due to air is neglected, the total sum of potential energy and kinetic energy at each point of its path remains same. Next, I am going to discuss in brief about the production of hydroelectricity. Water in motion in a river or sea has kinetic energy. We know that in motion, which energy is there? Kinetic energy. The energy possessed by the flowing water is called hydro energy. The most important use of hydro energy is what? To produce electricity from it. Clear? Now, the flowing water of a river is collected in a dam at a high altitude. The water stored in the dam has the potential energy. When water from the dam falls on the water turbine, the potential energy of the water stored in the dam changes into its kinetic energy, and this kinetic energy of water is transferred to the blades of the turbine as the kinetic energy which rotates the turbine. As the turbine rotates, it rotates the armature of a generator to produce what?